A warm welcome to the Big Data Conference in the Machine Learning track, and I will be your host, Priyanka. So let us start this session. We all know that machine learning holds the potential to drive the economy towards increasing productive growth. Our today's speaker, Diana Gabrielyan, will illustrate on this with an important case study, and she will address on her talk Machine Learning Helping the Economy. Diana is a lead data analyst with one of the biggest retailers in Finland. I now invite Diana to present her talk.
Thank you, Priyanka. Hi, everyone. It's really great to be here today. Hope you're all having a great time and excited for the conference days ahead, even though we still have to stick yet again in front of our computers. Today, I'll be talking about how machine learning can help the economy. But before I go on with my presentation, let me introduce myself, even though Priyanka said a few words already, but I already prepared the slides, so I have to go with them. So this is officially what I do. I'm currently leading the analytics team in Stockmann, which is one of the biggest retailers in Finland, with both brick and mortar store and also online store. I'm also finishing up my PhD in quantitative economics at the University of Tartu. And at the same time, I'm teaching there data analytics for bachelor and master students. But the second picture summarizes my life pretty much in this one picture, which was taken by my friends when I was presenting at a conference in a summer cottage in the summer in the middle of nowhere, and I had to do a presentation. So this is pretty much my life, trying to juggle between the work and the PhD. Okay, enough about me. So let's see what we have on the menu today. So I'll start my presentation with the definition of machine learning in economics. It's describing the advantages of using machine learning in economic modeling and decision making. So a little bit of theoretical background to understand the importance of this topic. I'll then proceed with a few examples of real life use cases of machine learning in economics and tell you about a few really cool projects that inspired me and my own PhD thesis topic. And lastly, I'll present you my own work and how I use text mining, which is a branch of machine learning for inflation modeling, and how the world can benefit from it. To give you a bit of background on why I chose this topic today, as opposed to, let's say, talking about how big data is used in retail companies or how I use it in my day-to-day job, is because so when I was starting my PhD, I knew I wanted to do something meaningful, not just spend 4 or 5 years of my life doing a PhD for the sake of getting a diploma. So it took me a while to understand what I really want to do. So what I was looking for is something that will make an impact for the world. And of course, we all have heard about the Tesla self-driving cars, the Uber and Netflix network predictions, voice recognition systems, and all that. And everything is super cool. But unless we're able to accurately assess the economy and make predictions, the technological progress and economic growth won't be possible. And for example, the COVID-19, which started early 2020, showed us just the importance of just that. It showed how important it is for policymakers to do timely and real-time analysis of the situation for the economy to react to any crisis much faster and better. Had this been possible in 2008, who knows what the impact of the financial crisis would have been. My guess is that it would have been less if we were able to predict the crisis beforehand, before it started and hit the whole world. And for example, the Bank of England has learned its lesson, and currently, in line with their financial stability objective, they're now using machine learning methods to predict the probability of financial crisis 2 years in advance. So basically, if policymakers aim to predict 80% of financial crisis, but while limiting the false positive ratio to 20%, then the best performing machine learning model would reduce the error rate by 40% compared to standard linear models. So you have better chances in predicting a financial crisis and therefore preventing a new worldwide crisis. Okay, and it's really hard to, harder than one may think, to come up with a good definition of ML. It's a really broad term that it can refer to anything, to any subfield from computer science to engineering to statistics, and also quite recently in social sciences, which economics is part of. And obviously, I can devote a whole presentation just talking about what ML means in, or giving a definition of ML, but don't worry, I will not do that. A good summary is given by Susan Athey, who is a professor at Stanford University Graduate School of Business, and her summary says machine learning views empirical analysis as algorithms that estimate and compare many alternative models, whereas in economics, in principle, researcher picks a model based on some principles and estimates it once. So what this means is that in traditional models, you only had one attempt at a model, whereas with machine learning, you have this set of algorithms that then help you compare alternative models or predict alternative models, which gives you more opportunities and then therefore more results and less errors. Okay. So now, continuing with what machine learning means for economics, to prepare you for what's to come next with the actual applications. So there is a great overlap between machine learning and traditional economics. A lot of topics in machine learning, such as causal interference, predictions, efficiency, have always been a fundamental part of statistics and econometrics, way before machine learning became this buzzword that it is today. There are still a number of methods that have not yet even been incorporated in mainstream machine learning, and similarly, of course, a lot of models in machine learning cannot yet be applied to social sciences. So for example, Netflix prediction system or Siri's voice recognition, they're super cool, but they don't really answer questions about causality and correlation, which is the basis of economic theory. So this is the reason why some economics are still skeptical about use of machine learning algorithms, as they argue that if you can't really determine whether a connection between a statistically linked pattern is a coincidence or an actual cause and effect relationship, then you can't really trust your results. But it has indeed been proven both in the academic literature and also in the private sector that machine learning does indeed yield improvements in estimations of economic models. One such example may be, for example, when the goal is semi-parametric estimation, or when there are a large number of covariates compared to number of observations. And in these cases, ML is able to add really great strength in variable selection and more flexible relationships. Similarly, traditional econometric models may fail to summarize non-linear relationships, or just when the data is too big, the traditional econometric models don't work. Whereas ML models such as Lasso, LARS, elastic nets, neural networks, and forest do a really good job in detecting and summarizing relationship. So for those of you, if you're interested in reading more how econometric models can be applied in machine learning and vice versa, the Halvaryan, he's the chief economist in Google, he's written a paper in 2014 where he, on various machine learning methods for available to econometricians, and he provides a really good summary. Of course, a lot has changed since 2014, but it's still pretty interesting for those of you who are either from economics or are looking ways to apply machine learning in the social sciences. And there was a PwC study that said, or that found that machine learning in economics can increase productivity by up to 14.3% by 2030, which I think is a really, really great number, because obviously that's what the government and public sector is trying to do, always increase the country's or the economy's productivity. Okay, so now I'll proceed with the use cases, and then I'll move on to my own research. For decades, the economists have been building their assumption about the prices, inflation, unemployment, etc., on the data that they, as large as they could calculate. However, as Esther Duflo notes, machine learning has the ability to has the potential to dramatically enlarge those data sets and allow economists to test their models faster than ever. For those of you who don't know Esther Duflo, she's on the photo on the slide along with her husband. Abhijit Banerjee. I hope I pronounced his name correctly. Some of you may know them because they recently won the Nobel Prize in Economics back in 2019 for their unique approach in tackling poverty that uses artificial intelligence and machine learning to deploy findings of their research in the most efficient way possible. So what they did, they used ML algorithms to effectively analyze population data and answer questions related to poverty and urban planning. And in one of their studies, which they conducted in Asia, Europe, and I think USA, they reported significant welfare gains from an intervention that helps the poor simultaneously in multiple ways. So basically, their machine learning allowed them to pinpoint where the program is most effective, and therefore where a government with a limited budget would want to expand it. Their approach is currently widely popular in India, Sri Lanka, and many other countries. And obviously, I only briefly explained what they did, but you can imagine if it's worth winning a Nobel Prize. I think it's amazing that they were able to use machine learning methods to tackle poverty, right? In such a way that I never thought this would be possible, but it's really cool. Okay, another example. This is my favorite. This, I think it's one of the coolest projects in academia, and one of the examples why I think academic research and investing in such research is crucial. It shows how a combination of ML, big data, and economic data can work together to pretty much do wonders. So Billion Prizes project is a project founded by two MIT professors, Roberto Rigobon and Alberto Cavallo. And back in early 2000s, they were thinking what would be the best way to measure the inflation, because that's pretty much what the government are always trying to do, or the central banks. And they felt that the organic data would be the best way to go. And those of you who don't know, organic data is the one that is generated without the intention to generate the data. So therefore it's truthful because it's unintentional, and it's also fast and cheap. So what they did, they started collecting supermarket prices from all over the world. And at the moment now, this project collects and monitors daily prices of about 15 million items sold by more than 1,000 retailers in more than 70 countries, including the Baltics. I, by the way, had the pleasure to hear him talk this summer in Estonia. And what I learned is that the spin-off company of this Billion Prizes project, which is called PriceStats, is now collecting data from the Baltics and particularly in Latvia. So I'm very keen to see the results and more research stemming to this. So if you're interested, follow them, and I'm sure they'll publish the results soon enough. So the image you see, the map you see on the screen, is a slightly outdated countries where they collect the data from. As you can see, there are dark blue countries where the inflation index is already available. Then there are newer countries. I think Canada is in one of the new ones, but this is from 2013. So I'm pretty sure now they already have the inflation index for Canada. And then there are countries where they're just collecting the data. So the idea is they're pretty much covering the whole world at the moment, maybe except few African cities. And from Latin America, they're not collecting data from, I think, Venezuela. And as Roberto Rigobon said, and he's actually half Argentinian, he said that he will never collect data from Venezuela because many years ago, Argentina lost to Venezuela in a soccer game. But yeah, they're trying to collect in as many countries as possible. So basically, the methodology is as follows. They're using scrapping methods to collect prices from online supermarkets every day for specific items in all of these countries. And after they collect the prices, they're using the same logic as the national statistics offices or central banks are using to construct inflation, except instead of the survey data, which is usually what the central banks are using, they're using these prices from online supermarkets. And for those of you who don't know, or who are not coming from economic backgrounds, the inflation is usually constructed based on these offline prices, so the supermarket prices, the one that you go to supermarket and see, and not only supermarket, because there's also inflation is also affected by prices of energy, travel, entertainment, etc., etc. So all these items together, they comprise the consumer basket. But of course, the online data is much better in most of the cases, because for some items such as clothing, electronics, entertainment that have a really quick turnover, if you wait the next month to go collect the real prices, then the prices might have changed already. Whereas in the online environment, you're able to collect the prices daily. So after they collect the prices, then they this is the part where they use the big data, or where they get the big data. Then they use machine learning to do predictions through nowcasting. So on a daily level, their index is able to forecast what would the prices be at the end of the month. Normally, the central banks and the governments only publish their inflation index once a month at the end of the month. But with their method, you're able to already today be able to predict what that inflation will be in a month. The inspiring part of this whole billion prices project is when they measured the Argentinian inflation using the supermarket prices, and then compared it to the real government published inflation, and basically picked a fight with the Argentinian government. So starting from 2008, they started publishing inflation rate in the website. It's called Inflación Verdadera, so like a trueinflation.com. And so basically they started publish their inflation index versus the official inflation index, which you can see on the figures that I added on my slide. So there's the daily index of inflation, and then there's the annual inflation. Mostly the central banks are using the annual inflation. And you can see in the this dotted version of the lines, we have the official index, which is pretty low compared to the other one, which is the solid line, and that's the online inflation. Basically, they estimated that the actual inflation is around 20%, whether the government's official figure was 11%. So the actual inflation was twice as big as what the government was publishing. I think it's an incredible difference, and it's not like it's 2% and 4%, it's 11 and 20%. So it's a really big difference. So basically, their index, not surprisingly, became widely used in Argentina. And what happened next is that the Argentinian government stopped publishing the data about the inflation. The IMF, the International Monetary Fund, put them under investigation because they didn't trust the government data. And long story short, the impact that I was talking about is that the public and international organizations realized how the Argentinian government was manipulating the prices and also the public trust. So they ended up stop publishing any inflation data until 2018, when new government was elected, and they started publishing the true inflation, the truthful and realistic picture of Argentinian inflation. If there are any Argentinians listening to my talk, please write in the Q&A or in the chat. I'm really curious to hear your experience with this, and if you even noticed what happened, or you knew about this project. But I personally find it super cool and very, very impactful, and the real reason why this kind of research is needed. Because usually in the private industries, you don't really have time to do such researches, because you're being paid to achieve this or that target. Okay, now finally I'll move on to my own research, and before I show you the tools and methods I use, just to give you a small background, what am I trying to do? So usually the surveys show that the household expectations about the future inflation differ strongly from those that are published by professional forecasters. And the reason is that subjective inflation expectation and nowcasts are built through prior personal experiences, prior memories of inflation, and various sources of information. And therefore, these all can be irrational, inaccurate. And it is quite intuitive that media coverage directly affects our inflation expectations. Think of the last time you read some terrifying the news, which is what we're doing the last 2 years, right? But think of how that affects our inflation expectations, right? When we read that, okay, a crisis is coming, or the prices have dropped, or now just today or these days there were news in the UK that there is this gas shortage, etc. So obviously these affects our inflation expectations, and to some extent the news reflect the current state of the economy, and it is possible to understand the importance of a given topic based on its intensity and the extent of how much it is discussed in the news. So then I thought, okay, if we have the news that are published daily and they are able to accurately show the sentiments, these expectations about future that the household build, why not use news data to build a real-time and accurate measure of inflation expectations? And so this slide shows just that. In the next few slides, I'll talk about how I came to build this figure, but just to give you an idea of what this is showing, this figure illustrates the relationship between the sentiment index constructed based on news coverage, which you can see in, I think it's turquoise or blue. So it's that one, not the red one, in comparison with the UK's official consumer confidence index, that's in red, and that's the official metric by which they measure the consumer sentiment about the economy. And you can see the similarity in shape and trend of the curves. We can see a very strong visual correlation at some parts, or at some time periods, the correlation becomes as high as 0.6, 0.7, which is really, really good number, which indicates that the sentiments that consumers build through the news do actually go in line with the official indices. And we can also, so the shaded lines, these green shaded areas, they represent the shocks to the UK economy. In general, the data I'm working is for the UK data, and these shocks around 2008, you can see it's the financial crisis period, and you can see that both this consumer confidence index in red and also my index, the news-based index, they both fell strongly around the financial crisis of 2008. Then they gained an upward trend, started dropping again. The official index started dropping again in the next shaded gray area, which is the period leading to the Brexit vote, even though my news-based index doesn't show as much of a drop. And then obviously around 2020, you can see the impact of coronavirus on consumer sentiment, both from the official measure and also reflected from the news. So this is part of my thesis. This is not the whole thesis or not the whole paper I'm working on, but this is just more of a validation that the news are actually quite representative of consumer sentiment. So I'll show you in the next slides the tools and the data I use to come to this figure. So I collect two types of data. One comes from the official statistics that are the published data set from the National Office of Statistics in the United Kingdom or from the Bank of England. I won't go into the details because that's the boring part. I think you're more interested to hear the novel data part. And the novel data source comes from the online newspaper that's Guardian. I'm sure many of you have heard about them. It's one of the leading newspapers, and they provide this API through which I collect the data from 20 years. In total, the data is unstructured, obviously, and it's around 100,000 English language articles from their business section, and around 20 million words in total, which is sufficient amount to construct robust analysis. Okay, but obviously this amount of data, 20 million words, 100,000 articles, is computationally challenging. So some pre-processing is necessary on the newspaper corpus, and luckily R has some really nice packages for natural language processing. So text mining in general is, I think it's part of the natural language processing, which itself is part of the whole machine learning. So yeah, R provides really nice packages such as the Tidy, word cloud, TM, and many others. I personally prefer to work in R. I've used Python before, but I prefer R. So most of my analysis are done in R. Okay, so the words are analyzed as a single token. There is this approach which is called bag of word approach in the natural language processing or text mining, and that means that I don't care about the grammar and structure of the words, and this is the most popular approach so far that I've seen. Okay, so I proceed then removing metadata from the data, so such as like images, links, or some unknown formats. These steps also include removing empty and duplicate entries. Then I proceed with tokenization, which splits the string into smaller tokens or words, or numbers, symbols, etc. So basically the whole sentences into separate tokens. This is sometimes also referred to as lexical analysis. All these tokens are then normalized, so converted to lower, and then the stop words in English language are removed. The stop words are those such as like and, is, like, but, and so on and so forth. So the words that are not really bringing any value and are just adding noise to the analysis. Then to remove or to reduce the dimensionality further, I stem the words. Stemming is similar to taking the root, but there is a slight difference. So for example, if I take the root of the word inflation and inflationary, they would both become inflat, so that's the root. But for example, and also the stem would be the same. But if I take the words tie and untie, the root will be tie, but the stem would still remain tie and untie because they have different meanings. So stemming actually kind of addresses the issue of keeping the meaning of the words. And the last step is, of course, building this document term matrix, which, as the name suggests, is like a matrix that contains the most common words in the across all documents, and then their corresponding frequencies in the other column. I also remove the sparse terms, so those terms that are missing in more than 90% of the document. So if one word appears in a document in only, let's say, 2 articles over 20 years, then I don't find it valuable enough to impact the consumer sentiment. And the results of this pre-processing is shown in this word cloud that you see, which summarizes the results by visualizing the most common words in the corpus and differentiating between the words color and size, indicating the frequency interval. And so, for example, price, year, and wheel, these are the words that occur the most frequently and are in the same range of frequency, followed by, for example, bank and market. They occur with the same frequency, but they occur less than the words price, year, and will. Okay, so again, all this is done using R's powerful commands. And now next is the actual machine learning part. So I hypothesized that, I have these 100,000 articles, and not all of them will be relevant to the inflation, even though they were taken from the business section. But it's intuitive, right, that not all of them will be pretty relevant, because some might talk about, some businessman that just got married and for whatever reason that ended up being in the business section. So some kind of topic filtering is needed. And therefore I use topic modeling, which is a process of looking into a large collection of documents and identifying cluster words based on similarity, patterns, and multitude. Any document can be assigned to several topics at the time. So some probability distribution across topics is needed, and that's where LDA comes handy. So that's LDA, or latent Dirichlet allocation, is an unsupervised learning model that's used in topic modeling that assigns words and documents to multiple topics. So it kind of does a topic probability distribution by assigning the probabilities to each word and document. And this has advantage of semantic flexibility. So let's say if we're taking the word rate, that can both refer to inflation topic and also unemployment topic, right? Inflation rate, unemployment rate. The formula for LDA is given on the slide. You don't have to focus on it, just kind of showing that it's a probability. It's based on probability theory. The idea is just to estimate the theta and beta in order to estimate which words are important for which topics and which topics are important for given document. And there are many approaches to do the LDA. I personally use the KEEP sampling method, which is an algorithm that successfully, it's an algorithm for successfully sampling conditional distribution of variables whose distribution over states converges to the true distribution in the long run. But there are many other methods that one is able to use depending on your needs. So these are the results of LDA. Basically, I use the number of topics to extract is based on the analyst's intuition or domain knowledge. So I personally chose that 80 topics would be relevant for this whole 20 years of data. But of course, I could go with 50 or 120, and I did try them. I found that 80 is relevant, and there's also some tests one can do to find the optimal number of topics. So in total, I extract 80 topics using LDA method, but I couldn't include them all in one slide. So I've only included few of them, just to give you an idea of the result. And LDA itself does not assign labels to topic. I do it myself based on the most frequent words for the given topic and based on my subjective understanding of the economy. So for example, if we look at the top left chart, this one, it's called bank and / England, but that's because I saw that the word bank and England are the most occurring words in this topic. So then I assume, okay, then this topic is about Bank of England. Similarly, there are other topics. If we look at the last line and we look at the middle one, we see that that's the topic talking about the coronavirus because that's the most occurring words. All right. So then again, besides the topic modeling, so topic filtering, then I also assume that not all news may refer to the event in the same period. So I also group the topics according to the timing of events that they represent and classify topics by those referring to the past, present, and future. Because if we're talking about inflation expectations, and obviously inflation expectations are talking about our expectations of future. So I need to, out of these 80 topics, I need to also extract those that are actually talking about the future, because I don't care what happened in the last 5 years or even 2 months ago, because those do not really affect my expectation about the future. The news that do affect my expectations are the ones that do talk about something that will happen soon. So yeah, that's what I do. This is a simple method. It's nothing fancy, so I won't go into the details. And then after I chose these topics, then I use the formula which you see on screen, basically trying to find the frequency of each word, of each document, of each topic for every day. So for the 80 topics, I have 80 time series that represent the frequency of these topics. And you'll see the results later on. Yeah, here. So these are again only few topics, but you can see, let's have a look at the one again in the one that's on the bottom row, the middle one, which talks about coronavirus. You can see obviously the topic also includes other words than the coronavirus. That's why it has frequency even before that, but you can see how it just picked in 2020 when it became such a buzzword. And these, what you see, are measures of volume or intensity. And economic research finds that we also need, in addition to this intensity indices, we also need some sentiment indices for capturing the true inflation expectation. So just the intensity alone is not enough. So in order to get the final inflation expectations, I augment these intensity indices with the sentiment indices by just multiplying the two. So I have my intensity index ready. Now I build my sentiment index, and then I multiply them to get the final inflation measure. Okay, so yeah, like I said, the research shows that sentiment analysis and its ability to classify articles into positive, negative, or neutral sentiment is a key step in my analysis. There are a number of methods to do sentiment prediction, and each of methods have their own limitations and pros and cons. But I use the most popular one, which is based on dictionary methods. So there is a financial dictionary, and I find that more relevant for the Guardian data, which of course has let's say thousands of words in it, and based on that I count how many words in my each topic are positive, how many are negative, and using some formula I calculate the sentiment index. But then in addition to this, I also use these dictionary-based methods with valence shifter words, and these are the words that actually may change the context of the words. For example, if there is a very big increase or must not increase, then I account for these shifter words. Otherwise, if I only take increase, I don't really know if that's positive or negative. So these are called valence shifting words, and they are very important to include. Okay. Okay, so now this is the result of the final inflation index. This looks quite messy, but just to show you how different topics look together, we can maybe only have a look at a few of them. So the pink one on the very end, that's the coronavirus topic, and you can see just how clearly the sentiment or the inflation expectations fell around 2020. Then they slightly increased back, which is expected, right? Because in the beginning it was very bad. We all thought that the end of the world is coming, and then we came back, or the expectations became better, but of course they didn't come back to the to where they were before. Similarly, if we look at like blue lines, I don't know if you can see them clearly, but we can see how they constantly kept falling around financial crisis, around Brexit, and so on and so forth. So obviously I included all of them in the same time, but if I look at all these topics individually, and these are the topics that are referring to the future, I can see just how in line the trends are to the actual inflation trends. The quantitative value is not really important here, because obviously you can see that mostly it's in negative range. So I'm not aiming to predict the actual inflation as a number, but I'm aiming to predict the trend and to see where it is going. And so that's the application. That's where I'm applying this in forecasting, what I just did in forecasting. So there are a number of ways to do that, but I also, so one way is to just use the topic that I find the most relevant to do the forecasting. Another way is to use lasso, which is another ML method that also reduces topic dimensionality, but also tackles the issue of multicollinearity. You could see from the previous slide that the topics have, some of the topics have multicollinearity among themselves. So I didn't include a lot about lasso, and I don't think I have much time left. But the idea is that, so I did inflation forecast using lasso method, and what I found is that when I use the best value of lambda, which is the shrinkage parameter in lasso, and I use optimal number of topics, I'm able to forecast inflation better than the simple autoregressive models, which is what is sometimes used, or is used in many central banks across the world. So yet another proof that I'm able to use a novel data, I'm able to apply machine learning, and I'm able to use forecasting through machine learning to be able to provide better results than what is currently traditionally done in public sectors. Okay, that's it from my presentation. I hope you enjoyed it, and keen to answer any questions you might have.
Yes, Diana, we have a question like, as you mentioned, economic crisis.
Yeah.
Did you do any type of research or analysis regarding the China Evergrande situation?
No, I didn't. And no, I have to even say I'm not familiar with the situation, so I haven't.
Going on to the second question is that if we build economic statistics based machine learning model, but because of one person tweet like Elon Musk, the whole market will change. So is there any possibility of using social media data models, including in economic model?
Of course, and I think that's the future, and that's one of the reasons why this is also very important, because if, you know, when Elon Musk tweets something, and we all know what happens, that will only get reflected in the official statistics in a month, or sometimes even in 3 months. For example, GDP is published every 3 months. Of course, I hope it doesn't affect the GDP a lot, but anyway, whereas if we're using the social media data, that's timely, that's real time. So we're able to uh, already answer these questions straight away. So obviously, and there are many, many more research that use, for example, Google searches data to predict unemployment, and it's a very successful research. If you check the Billion Prices project, they're using the supermarket prices also to predict the COVID sentiment at the moment. So there's a lot of things you can do with the social media data, and a lot of people are already using. For me personally, one limitation would be that if I want to use Facebook data or Twitter data, and I tried using the Twitter data in the beginning, but if you want bigger data, which is what you would want to have robust results, you need to pay for it. So at the moment, I'm in academia, and academia doesn't really have that much resources to pay for, let's say, Twitter data. But unfortunately, the limitation is that you need to pay a lot of the times. But in the private sector, obviously, it's more possible.
If you have any questions, please type it in the question and answers tab. I think we have answered this thing. Even I have a question. It's like Elon Musk tweet. Is it not an outlier? I mean, these are like just one person tweet, and the overall market sentiment has been just upside down. So how do you deal with such certain things?
I think Elon Musk is a special case because for him, I think the change is very immediate, but it's not really that long lasting because he changes his tweets pretty often. In general, so I don't know how I would deal with him because I haven't had the need for dealing with his own tweets and sentiments that result. But in general, I think with the outliers, it really depends. You obviously see that in your data, and it depends what type of outlier that is. Let's say COVID, you might have thought that's an outlier because that wouldn't last long, but then you see it does last long. So it really depends case by case and what kind of outlier that is. Similarly with the ex-president of United States, right? That outlier lasted for 4 years and still has this kind of an impact.
Right. Perfect. So last word of thanks. In case if audience you have any questions, please
I
approach
think
the
we have
speaker's
some
profile.
questions. I can see we have still some questions.
That has been answered. Okay. Yes. Is there a possibility of using this kind of sentiment analysis for the real-time stock trading?
Yeah, it is, and I've seen some research with this. I think actually many. I think I've seen some paper in China, a lot in US, a lot in Germany. So people are using indeed sentiment analysis for stock trading. I'm sure if you just Google, you'll find a lot of interesting papers.
And this is the last one. Are institutions adapting this approach, or do they still stick to the old Phillips curve?
They're starting to, and that's what I'm aiming to. Obviously, the central banks, they're not really keen to changing their methods for something new and something so uncertain. But they, at the moment, they mostly stick to their old Phillips curve. But like I said, for example, Bank of England, they have adopted, or they're now starting to include machine learnings for many of their prediction purposes. So I'm sure this will come, but at the moment, it's still old Phillips curve.
All right. I think that answers your question. So any further questions, please reach out to the speaker's profile. We are running out of time, just sorry, but I would just like to end this session. And by thanking our speaker, Diana, for such an informative talk. And I also thank the audience for the intention and interest. And last note, please rate the session and comment on the sessions also so that you get your free ebooks, right? And thank you, speaker. Thank you.
Thank you, everyone. I hope this was interesting for you. Okay, I will end the session now.